Welcome, everyone. And like I was saying before we went online, I was so happy to see this finally happen where we were going to be beyond capacity of this particular room. So, yeah, thank you all for joining. So my name is Paul Baylog. I am the, local somewhat these days. I've moved actually to relocated out to Columbia, Missouri. But I am a CNCF ambassador as well as a GoBridge ambassador for the GoLangs. Michael Madden, who surprisingly, he works here sometimes in this facility. He wasn't able to make it apparently. So anyway, sponsors, just wanted to thank everybody for that. GoBridge covers all the fees that are taken up with the Meetup group. And fees are for food, and the facilities are covered by my employer, Grafana Labs. So, yay. And I guess there was just enough food. Usually it's about a 50% rate of people showing up on RSVPs. So, yeah. So I try to, time it just, or do it just right with the amount. So anyway, some of the things that are coming up, just in case, GopherCon's coming up in San Diego in September. Unfortunately, my talk was not accepted. I'm a little upset about that. So, but anyway, I will be presenting it to the group sometime when I have it all ready. So be ready. So yeah, job board, Grafana Labs. We're one of those places we're kind of hiring all the time. I had to take off the one for the St. Louis Cardinals because, we advertised that last month, and then apparently that's been filled. I don't know. Anybody else know of open Go positions around the area or fully remote? With Grafana Labs, they're all fully remote. We have no offices. I lie. There's one in Stockholm, Sweden. I've been there, but they're just waiting for the lease to expire. Give it about 3 years. But yeah, hearing none, we'll go on. We are moving. So this is the last event we're holding here at Cortex.
I was all happy I was here, times for my work.
Yeah. Well, yeah, we weren't getting the great turnout, and it was a little bit more expensive. It exceeds my co-working budget to have the facility here. And now that I'm in Columbia, I'm not going to be here much, except for one or two nights a month. So we will be moving back to where the Go Meetup was held pre-COVID. So that's out at Olive 270. So, and it's a much bigger venue as far as the meeting space. So we won't run into this for a while, unfortunately. But I'll look forward to that day when we outgrow that facility. So, anything else going on in the community that people want to talk about? Go related or even CNCF. I lean to everything cloud native anyway, and Go being the prominent language with that until I get into Rust. All right. Well, hearing none. Nathan Nutter is going to be speaking to us, so I will let you now switch over. So let me get out of here. And
all right, so yeah, I'm Nathan Nutter. I'm a data engineer at St. Louis Cardinals, and I have a bunch of my coworkers here with me, representing different parts of the pipeline that we do. And the talk I'll do is just an introduction to web scraping and Go. Hopefully it's not too shallow, but you never know what people's skill levels are and stuff, so didn't want to assume too much. So the first thing I'll kind of go through, I'll just talk briefly to introduce some stuff, and then we'll switch to code. So there's kind of like several layers of abstraction you could possibly use in web scraping, and the lowest would be just doing raw HTTP requests and just looking at the text. The next layer up from that, you can parse the text into HTML usually. And then beyond that, you can start to use libraries that implement like CSS selectors, so you can easily inspect the HTML DOM tree. And then even beyond that, there's like a tool called Collie that will also add a bunch of other features you might need for web scraping, like rate limiting, caching, sessions, cookies, stuff like that. I haven't used Collie very much. The main thing I've been using in the project I'm on is a project package called Rod, and we'll get into what that is in a moment. But to look at some code, so hopefully, yeah, it seems like it's pretty visible. So I have set up a bunch of examples as tests, so I can run them here potentially. First little bit of boilerplate is just a little server I set up. I just downloaded a web page from the NCAA stats website, just hosting it locally. And so you'll see that on every test, and it's not particularly important. And then this example here is just the very low level one of just making an HTTP request and looking at the body. So doing a get on that page I'm hosting, and then reading the body, and then just printing it out for you guys so you can see HTML, which hopefully everyone's sort of familiar with. All right, so there's a large HTML document here, lots of tables and data and stuff in there. I can also show you what it looks like rendered. So I've stripped it down a bit, partly just to make the demo simpler, but basically I removed most of the CSS formatting and stuff. So it's not pretty, but this is the page. It's several tables. They got the scoreboard for a baseball game here. They got stats for players on the two different teams. And in this case, it looks like hitting stats. So maybe in the most basic case, maybe this is all you would need is just make an HTTP GET request, and then maybe just use regex or something to inspect the text. And an example I've done with this is when iPhones launch, I'll sometimes write a quick thing to tell me when the pre-order button goes live. So the next layer up in abstraction would be to take this HTTP output and parse it as HTML. So more or less, this starts off the same with the HTTP GET request. And then just using the HTML library, and this is from Golang's XNet HTML package. It's an HTML5 parser. So it just parses the body into an HTML tree, DOM. And so it gives you the ability to sort of walk the tree. You can traverse children and siblings and crawl through the tree looking for the nodes you care about, the information you care about. But implementing that by hand is sort of cumbersome. This is an example here. I wrote a function to look for table tags in the HTML. Which, by the way, if you have any questions, just ask whatever. Like, don't mind being interrupted or anything. So to find those table nodes, it's a recursive function. Basically, if you get to the end of the thing, you're going to bail out of recursion, and then for all the children and siblings, you're going to dive deeper into it. If you find what's called an element node, so this is a tag like table or A or whatever, then if it happens to be of the same type I requested table, then it will return that. And then this is just the aggregation for recursion and stuff. So crawling the tree like this is pretty low level. You would have to handle different types of nodes. Like eventually you'll get to content nodes where you have actual text. You'd be able to inspect the attributes on the tags and everything, but it's all very manual. And ultimately, if you go a layer deeper and use CSS selectors, you can sort of avoid a lot of this tedious part. I'll run this real quick just so you can see that it does find the tables. So it just crawled the whole tree looking for anything that was a table, and it found 7 tables. So the next layer up will be the CSS selector idea. So there's a library called Cascadia. But I'll switch back to the slides for a moment and talk about CSS selectors in case they're not familiar to folks. Okay, so CSS selectors, I mean, I don't know, does everyone know what they are already? If you've used them, most likely it's because you're writing a CSS document for a website and you specify a selector and then a block of attributes to apply to the nodes that match that selector. So they have terms for these. This is from like the Mozilla documentation. So a basic selector, there's 3 types. There's the element type, which is matching HTML elements like a table, div. There's class name selectors, which are just prefixed with a period. And that matches a special attribute on a tag called class. So there's an example here where if this anchor has class equals foo, then you would be able to find that node by looking for .foo. Does the cursor show up? Yeah, okay. And then the ID selector is very similar to class selector, but it's using the ID attribute instead of the class. And in CSS, typically class is used like how we use the word class in programming languages. It means a class of elements. So you'll often apply some formatting to a whole set of elements based on their class. And then if you have a very specific element, you'll use an ID. So like maybe you have a bunch of tables and you all want them to be formatted the same, so you give them the same class. But then like on the HTML, I gave you an example. If I was a good web developer, I would give those IDs like scoreboard, visiting team stats or something, and home team stats or something. And then you can combine those basic ones together. So you can combine like an element and a class, or an element and ID, or all 3. And that's called compound selector. And then you can also chain compound selectors together using combinators. So the most simplest one is just using a space. So A space B means look for all the nodes B, whatever the B selector is, that are under a descendant of A selector. So an example here might be that A is a table with a certain ID, and then B is all the rows in that table, the TR elements or something. And then the greater than is a sort of more specific version of that, where B is directly a child of A, not just a descendant. And then the tilde is a sibling, and sort of similar to the descendants and children, there's the plus, which is the direct child, the direct sibling of, so B follows immediately after A, as opposed to B is somewhere after A for the tilde. And then you can mix all that stuff together, and then it's called a complex selector. And we'll start using some of those to find tables in that document rather than crawling the HTML by hand. All right, so we're back to building up the abstraction stack. So we had the HTTP stuff, then we had the HTML parsing, and now we're adding on Cascadia library. This is a third-party library from Andy Ballholm. So just like before, we're doing the HTTP get. Just like before, we're doing the HTML parse. But now we get to the next piece. So in Cascadia, we can build a selector by using this Cascadia parse. And then we would specify our CSS selector here. Then it gives us back an object we can use. And then you can use query or query all, pass in the HTML tree and the selector you just created. And then it will find all the nodes in the HTML tree that match that. So let me comment this out real quick. So just like in the previous example, if I run this, it'll find the 7 tables. But in this case, I didn't have to write that find element node. I just used parse and query all from this library. And these versions are also much more powerful than the find element nodes I wrote or whatever. So, but now I can give you an example of a more complex selector. So here, looking for an ID called content area, and then a direct child with an element called table and a class called myTable. And then here I'm using query instead of query all. So it's just going to match the first node that matches that selector. And I'll comment out this one. Don't care anymore. So this selector just matches one table, and it happens to be the scoreboard table at the top of the web page. Oh, it's gone. Where is it? Yeah, it is. Okay. So that's matching this table here. So one thing that can be really useful is how did I figure out that selector to match this table, right? So most browsers have similar developer tools. This happens to be Chrome. So one thing you can do is you can just right click and say inspect. And whatever you clicked on, it will find that node in the HTML DOM. So in this case, it picked a link that was inside a table data element, inside a table row element, inside a table body, inside a table. So, but here's my table. So one, you can see, here's the thing with ID content area. And two, you can see the table with the class myTable. At least in Chrome, you can also right click on this and say copy selector. And then I'll show you what it gives me. So the selectors it gives you are correct, but they aren't necessarily like robust, good choices. In this case, it's using this nth child selector, which I sort of consider to be kind of fragile because it depends on the number of elements that happen to be in there. So if they add another table or something, whatever, it can break pretty easily. So one of the sort of arts to scraping is trying to figure out what selector is least likely to break. And ultimately, you're not going to get it right. And you will have to eventually update your program when the website changes. But we can get a starting point. And then otherwise, you just look at the HTML and look for hints of things that you think will be stable and useful. And it's an art more than a science, I guess. So we now have a way to target that table we're interested in scraping for this demo. In a moment, we'll actually like scrape it, but I want to quickly talk about Collie. So, well, sorry, first GoQuery, I guess. So GoQuery is a lot like Cascadia. It gives you a library that you can use CSS selectors to find nodes and stuff. It was written to mimic the JavaScript jQuery library. So if you already had experience using jQuery, it might be an easier entry point for you. However, I think it's part of HTML5 or whatever, but every browser now has the ability to find elements with CSS selectors. So I think jQuery is sort of antiquated in a way, but I am not a web developer, so I don't really know what I'm talking about.
Okay, but you know,
all right,
CSS
web developer approves. So one, I guess, since two paths to go down now in my brain. So GoQuery, it's a very popular library, which is why I'm mentioning it. Puerto Quito Bio GoQuery. Similarly, you're going to do the HTTP GET, but instead of using HTML parse, it's got its own at least constructor function. It may be using HTML under the hood. And then instead of having like that query and query all functions, it has find, and then it has this each. So this is a very like JavaScript way of doing things, like calling each on an array. So this is equivalent to the code before where it found the 7 tables, and then this is equivalent to the code before where it found the one specific table. I'll go ahead and run it, but like it's not going to be any significantly different output or anything. So, but finds the 7 tables, and then finds the specific table where I'm logging the selector and the node. So if you happen to be interested, if you happen to be familiar with jQuery, GoQuery might be a nice starting point, but I would suggest Cascadia is probably a better choice. And then, yeah, I guess now I'll talk about Kali real quick. So Kali is also very popular. It's probably the most feature-complete web scraping framework in Go. It's the one that I mentioned earlier that handles like rate limiting and cookies and sessions and all sorts of stuff. However, I don't really care for its API. It's also sort of very JavaScripty in a way that you have these like callbacks you register. So you instantiate a collector object, and then you bind these callbacks. So on HTML is a particular event in its scraping pipeline. I don't even remember what all the other ones are, but it's got like 7 different hooks in where you can intercept, change things, inspect stuff. And so you bind the callback. The style here is sort of combining, like in GoQuery, how it had the each. It's kind of like that. So you're giving a selector, and then you're giving a callback function to call on all the nodes that match that selector. And so this code is doing the same thing where it's finding all the 7 tables and then finding the one specific table. And after you bind all those callbacks, then you tell it to go visit the site, and it will just trigger your callbacks. So
you say you see that as the most feature complete of the library. What would you say would be kind of one of the big things that's in Kali but not in the others?
It's the stuff like the rate limiting, session handling cookies. So if
can it actually authenticate, like if it's trying to scrape a site that's behind a login?
I don't know the answer to that. I haven't had to work with any that have authentication yet. Everything okay?
Like a website or something. Yeah. But it could be a
JWT.
Yeah. Just or something like that.
Mm-hmm. All right. So the last piece here is ROD, and I'll actually dive a little deeper into ROD. Before I go too far, I want to rewind a little bit to how to figure out CSS selectors in the browser. So you remember I mentioned you can right-click on things, inspect. You can find it in here. You can right-click on it and copy selector. The other thing that's really useful in here is that you can switch to the JavaScript console, and this is where you get the native ability to find nodes. So it's document, and then query, selector, and selector all. So selector just finds the first thing that matches. Selector all returns all that match, and then you just give a CSS selector. So the 7 tables, I can just look in here, right? And so if I'm trying to figure out a good selector, I don't have to go put it in my Go program, run the program, and see if it worked. I can just work here, figure out a good selector, and then go use it in the Go program. So I can do like I'll show you something else too. So content area. All right, so one thing that's worth checking if you're using an ID is make sure it's actually unique, because some developers are bad and give the same ID to multiple things. Although hopefully maybe with a tag plus ID, maybe then it would be unique. And if you expand this node list and you hover over the elements in the array, so 0 here, it highlights it on the web page for you, which can be handy. So like when I want to find all the tables and I'm like not sure which one is the one I want, I'll just hover through these, right? I'm like, okay, I want the scoreboard. So now I know it's the first one. It also tells me here that it's got the class my table, which is a hint that I could maybe use that to help find it. And then I can add the my table. I get fewer. Now I just have 3. And it turns out that these 3 are the 3 data tables that I actually care about on this page, the scoreboard and the 2 sets of tables for the stats. So that document query selector all and selector is a pretty useful tool in the development process. So going to ROD, so new package. It's go ROD. The difference between this and say Kali, and the name refers to the sticks on a puppet. We'll get there in a second. So the difference between the Kali and all the other things we've done so far is everything so far had been using the native Go HTTP client and native Go code and stuff. Rod is an entirely different beast that its purpose is to drive a web browser. So it can drive Chrome or Chromium or Firefox, Microsoft Edge, anything that implements the sort of standard DevTools protocol, or at least in Firefox's case, it implements a subset of it so that it works with tools like this. Or more specifically with Firefox, they specifically mention wanting compatibility with Puppeteer. And what motivated using Rod was that we had prior experience on the team using Puppeteer. That's a tool for the Node.js world. And since I was in the Go world, I discovered Rod as something that was similar to Puppeteer and the fact that it used the DevTools protocol.
I had some issues with Rod. So it runs something called linkless because it actually starts an instance of the browser, and then you got to shut it down. Well, linkless puts an executable out in your temporary space and then tries to run it. And your antivirus doesn't like that because that's how viruses act on your system. So they said there was a way to not use linkless and defer just sending a message to it to close after you're done with the routine. And I tried that and it didn't stop it. So it was still hanging out there. I had to reboot my system to get rid of those extra processes.
Yeah. You could also, you can tell it to use, you can point it at an existing browser binary.
Yeah.
So you could point it at the one that's installed on your C program files, Chrome, whatever. I don't remember off the top of my head the technique for doing that, but
it's got a ton of properties that you can pass into it, and they're not all really apparent, in the initial information they give you about it when you look it up.
Yeah.
You gotta dig for them.
We can probably look for that in there on their docs too. See if we can find it real quick in a sec. But yes, so if you don't, out of the box, it will download a Chromium browser, I think always, and run that. But you can point it at a specific browser, and there's control there you can have, but it doesn't assume you necessarily want to use the one on your system. And that is helpful when you're deploying an app out into the world or whatever, I guess. But like the Docker containers we build, we install Chromium through the OS package management and then point Rod at that instance of it. Yes. Yeah. Which it also, so I haven't actually used it in non-headless mode, but theoretically that's also a useful tool for debugging, is to actually be able to see the browser doing its thing, especially if you get into more complex stuff where you're actually like clicking on UI elements and stuff. So with Rod, you instantiate a browser and you instantiate pages or tabs in that browser. You can use multiple browsers and you can use multiple tabs. You can also use incognito mode, which you might want to do if you want to try to isolate the pages more. And so besides that sort of overhead of creating the browser and the page, the actual usage is very concise, just like with the other libraries. It has every function it has on any of its types, it also has a must version of it that instead of returning an error panics. So the must versions are really nice if you're just like scripting a quick thing, but I would encourage you to use the error versions if you're trying to write something that's going to run for any amount of time. So, but for purposes of the test, I'm just using the must things. And so elements is kind of like query all or query selector all. It's returning an array, all the nodes that match the selector. And then the singular version element is going to return a single one. And so if I ran this, it will give us the same output that we've seen several times now. Well, sorry, not the same exact output, but fundamentally the same 7 tables and then the one specific table. And so here is where we actually can extract that one specific table into some data. So just selecting it. So just selecting the one specific table using that CSS selector we discovered earlier gets you the table node and then all the child nodes below it. So then I have this extract scoreboard function that we'll jump into and look at the implementation. So the T here is the whole table. And then we can find all the rows in that table looking for TR elements. And it turns out there's just 3 rows. First row is a header row that's got the innings of the game. The second row is the stats or the scores and stuff for the visitors. And the third row is the scores for the home team. It's a baseball convention that goes in that order. I'm using a library just to pretty print the extracted data as a table. So it's not particularly important, but that's what TW is here, table writer. To grab the data out of each row, I wrote a little helper function. Could have been named and been outside the scope of this function, but I just wanted it to be easy to see, so I kept it here. So all it's doing is once you have a row, it's then asking for all the TD elements, the table data elements. And for each one, it's calling a text function. And in ROD, that just means like basically give me the content of the node. So in this case, it's the values that are on the table. And it's just sticking them into an array. Here I can use cool new syntax with any. So it's just grabbing all the values. It doesn't care what they are. They happen to be strings, but the table library just wants an any type. So it's just grabbing all those values and then returns them. So then I call it 3 times, once on each of the rows. Grab the header row, grab the visitor row, grab the home row, and then spit out the table. And if we run the test, you get to see the super cool ASCII table. All right, so web scraping, ta-da. When we use this, we don't use like empty interface or any types. We would actually build a struct that represents the data we care about. And the technique I've been using, which I decided not to demo, but I'll just mention it, talk about it, I guess. So I have this note here for it. So we have a struct. In this case, maybe we take a type that we call scoreboard that's got like a visitor and a home field on it, with each of those things maybe having an arbitrary number of innings, because baseball games can go forever, theoretically. And then it has the special runs, hits, and errors columns too. And the technique I've been using is to tag those fields, basically just with JSON tags. And so in Go, you use these JSON tags normally to be able to output JSON in that form. We're using those JSON tags both to do that, but also to indicate the name of the header in the table that data is supposed to come from. So in this case, it would actually have like names like 1, 2, 3, 4, 5 and RHE and stuff as the tag names. And then using reflection to, instead of shoving things into any types, shoving them into those fields by matching up the header with the JSON tag name, and also trying to parse the string into the type of the field. I didn't want to show it because reflection code is sort of horrendously bad looking, and it's complicated, and it definitely would scare anyone that's not used it before. It's very verbose because you're at a very deep level. But it is a fun, it's nice because you can write that one scary function once, and then you could basically parse anything in the world by just defining a struct with JSON tags. All right, so scraping is done. At this point, I'll start talking about some helpful practices. But again, if you have any questions or anything, feel free to interrupt. I appreciate the questions I've gotten so far. I have tests here for each tip I have. So first note is something I got bit by is elements just returns whatever is in the HTML tree at that moment. And so if you have a JavaScript app that you're scraping or something, obviously the JavaScript can manipulate the HTML document, and it's fairly common maybe to like if you go to Amazon, like they load like 3 items like from the server, and then JavaScript starts injecting the rest. Like, so that's how they get really rapid page loads, but also give you the sense of a long list of products or something. So when you're scraping, you may have to worry about whether JavaScript is going to be manipulating the DOM. And so if you use elements, it just returns whatever's there at that moment. So you might have to like wait for a certain number of elements, or whatever sort of heuristic you can use to try to figure out when you think all the elements are available. To me, it was sort of a surprise, but element does not return immediately. Because you're sort of requesting the first one, it sits there and waits until one is available, which means if you mess up your CSS selector, it will just hang indefinitely because nothing will ever match it. And so we had a problem where I was leaking pages because they were just staying open forever.
Is one more library like Rod more capable of handling that lazy load model situation than the others? Or
so all the other ones don't run JavaScript at all. They're just HTML.
okay.
So if you need to worry about JavaScript, you basically have to use Rod. Okay. Or something. There are other packages besides Rod that do it too. Like I haven't used them, but Rod seemed like pretty good. So if you're looking for one element, so a few things you can do here. So one is you could write cautious code where instead of just trying to get the one thing, you could first say has to see if it exists. Or another option is, the second tip here, is you can add a deadline. So in Go, the sort of the standard way to handle timing out requests is called context cancellation. And the context package, which is part of the standard library, has 2 functions, like, well, 3, I suppose. There's with deadline, with timeout, and with cancel. So deadline and timeout are really like siblings of each other, because timeouts just get turned into deadlines. They're just relative to time now. And then the with cancel one is a manual cancel, where maybe you would have some Go routine watching for some exit condition, like, for example, someone sending Control-C on the command line to interrupt the program, and you could call the cancel function then. But so in this case, all I'm just trying to demo is that you can set a timeout on the page scraping. And so, like, if I had run this one previously, I'll just go ahead, whatever, do it. The elements ones will return instantly, and the test is verifying that, like, it didn't find anything. And then the element one will just hang because it's waiting for one to exist. And so I don't know, I'll wait like 3 seconds or something, and then it's not finishing, so I'll kill it. Bad test. This one, so it's the same idea, must element on a bad CSS selector, but now I've added a context that has a timeout of 3 seconds, and I've sort of injected it into the page using this context function. And so if I run this one, the test will fail, but it will terminate after 3 seconds. There. And then because I'm using the must, it doesn't return an error, it returns a panic, but it's panicking with context deadline exceeded, which is what I expect in that case. However, because those timeouts are a fairly common thing, they do have a helper function in Rod. It's just timeout. So this one line is equivalent to these 3 lines, assuming you don't need that context for other purposes. And same deal, if I run it, it'll exit after 3 seconds, which I guess we don't really need to wait for, but whatever. So there it is. Now, one thing, in my mind at least, if I'm using this timeout function, I sort of associate it with that must element call, but really it's for any calls that are like, so must element returns something, that is your element that you care about. The context is still associated with that thing too. So what can happen is, like, you add a timeout, call something, do a bunch of work or whatever, and then later on you're trying to get the content of a node. If you forget that you had that timeout there, you'll get a context deadline error. So the way you remove it is with this cancel timeout thing. So this one, it has a timeout 2 seconds. It's a good CSS selector, so it's not going to hang. But then I'm sleeping for 2 seconds. So at that point, the timeout's expired. With the cancel timeout in there, it reads the must text fine. If I take it out, then you'll get the panic again. Oops. So if you use timeouts, you'll probably also want to use cancel timeout. Go away. All right. So next tip is sometimes CSS selectors aren't quite enough. You can always drop down to like lower level inspection, but they also have these helper functions that end in R for regex that take a second argument. This is a regex that matches the text, the content of a node. So in this case, like if I wanted to look for the link, so an A tag that has the text box score, I can do that. Like, you know, supposedly there's no class name or ID on there that helps me. I can't figure out a good selector to identify it. I can fall back on regex and matching the text. And test is not very exciting, but it confirms that I find that link. Okay. Another tip is browser doesn't consider 404 and stuff like that to be an error. It's just a status code. Same as really the HTTP client in the library. Unfortunately, checking the status codes is a little bit tedious with ROD, but it is possible, and it probably is a good idea to watch for it. There are alternatives, like maybe just looking for content that says it's a 404, but if you want to actually check the HTTP status code, you have to do it this way. So first thing is, when I instantiate the page, I don't actually give it a URL to go to. This sort of weird UI, like it'd be handy if you had like a blank page helper function or something, but basically the normal page load function just passes the URL into this structure called target create target. And so all we're doing in this case is passing that in with no URL set. So basically it opens like about blank page or whatever in the browser. Then, well, just to explain this, I'm just picking a faulty URL that won't exist because I want to test for 404. So then to set up the functionality to look for the status code, you instantiate a network response received event. And then you tell the page that you want to like bind to that event. Then you tell it to navigate to the URL you care about. And then you wait for the event to have fired in the browser world, or whatever. So once that page has been loaded, that event will fire. This wait will allow you to continue. And at that point, the event will be populated with information. So the information that's here, a bunch of stuff. The thing we care about in this particular case is response and then status. And so this is just showing you that if I try to hit this URL, you get back a status not found, but 404. Anyway, so it passes.
Can you specify through that specific wait event to wait for like the appearance of specific tags or nodes like you were mentioning before?
Yeah, let's see. There's similar functionality. I'm trying to remember if there's wait. So there's like this wait elements more than. So this is a case where the Amazon product page example, maybe you would wait. If you know that they load 3 statically and then they start chugging in with JavaScript more, maybe you would wait for 4 or something. Whatever, you have to find what works for you. So that's a way to do it for CSS selectors. There's several events that you can bind. There's sort of standard browser things like the wait idle, wait load, wait repaint. What I've mostly just been using is wait event for this purpose. Otherwise, I've mostly just been using the wait elements more than function when I write my own code. And a lot of times I'll be waiting for a selector to be more than 0. So I'm just waiting for it to become present, which technically is the same as element. So checking status codes is there. By the way, the slides and all this code is going to be available. So, another useful thing is race selectors. So this maybe is sort of related to what you just asked, Jack. But race selector is, you could imagine a page loads, and for example, maybe there's a little pop-up for some sort of error, and you might want to capture that, detect it, and sort of relay the error. Whereas normally you're looking for the content in the page to load. So a race selector allows you to specify both selectors and a handler function for each, and then it runs them both in a like what's sort of equivalent to like a Go select on 2 channels type idea, where the first one that finds nodes returns and calls the callback, and then you get your results or whatever. So this is like an alternative maybe to checking status code. Is instead of looking for a 404 status code, you might look for a not found message, but also the normal content you want. Just whatever your preference is.
Can you specify as many races there?
Yeah, I think you can just keep chaining indefinitely. Whatever. In a particular case, I've only ever used 2, but I believe you can just chain indefinitely. Another useful thing is, since we're running headless, usually, we don't actually care about images, CSS, fonts. Maybe you don't even care about videos, whatever, right? Like there's a bunch of stuff you may not care about if all you're after is HTML data. So there's a way to block those resources from being loaded, which can improve memory and improve page load times and reduce the burden on the server. So sort of like with HTTP status code, you have to instantiate a page with no URL. Then the page has this hijack request function that returns back this thing, like I think they call it router. Hijack router. And then the router, you can bind different URL patterns or whatever, or probably it's path patterns, I guess. And then use these sort of callbacks, and this stuff's all documented. But basically, it's like looking at the request. If it is an image type and it matched the PNG pattern, then I will tell the browser that I'm blocking it. So network error, reason blocked by client. But other than that, I want to go ahead and continue on with the request. And just repeating that same pattern. So there's different types. So for CSS, there's type style sheet. For fonts, there's type font. JavaScript, there's TypeScript. This right here is also an example where I don't want to block all JavaScript on this one particular website where the host is statsncaa.org. I want to allow the JavaScript. But most of the sites I go to, I don't actually care about the JavaScript. Which also means I could potentially use all those other packages that we introduced before ROD, but it's easier to have one set of code than 2. So then ultimately you start the router, and then you go ahead and navigate to the page. And at that point, the router is running in the background or whatever, and it'll reject those resources, so you don't load them. And last tip is, since you're loading a browser, there tend to be pretty memory intensive applications, especially these days. So you may be running in a memory limited environment and want to constrain. There's lots of ways to accomplish this potentially, but one way is that ROD provides something called a page pool. So rather than opening an indefinite number of tabs or pages, you can tell it how many it's allowed to open and then use that pool of pages or reuse that pool of pages as you're working. So you instantiate a page pool, defer a cleanup function, which word for Go, or tip for Go developers, if you're providing a cleanup function, it's really handy to return a func that they can just pass to defer instead of having to wrap it like this. Then you're going to be using the page pool. So in order to use it, you do a get, and you have to pass in a function that's purpose is to return a page. And typically you're just going to like bind it to a thing that returns a page from your browser. but you might want to hook in some other like trigger along in there or something, whatever, so that they do it this way. Again, tip for Go developers, you could make it so you could just return a function. Actually, I wonder if you could just return. Yeah, you could just do a browser must page. Probably. Yeah, it doesn't work. Okay. So you do the get. In this case, I'm logging. So defer, putting the page back.
Oh, no,
Yeah,
I
yeah.
was just trying. Sorry, my bad.
Okay. So deferring, putting the page back. So when this function ends, it'll return. And just logging for demo purposes that the page is being returned. Then logging that I'm going to use the page and just navigating to a URL. Sleeping for a couple seconds just for the purpose of demonstration so you can see that the page pool is functioning. Which I guess I just skipped over the error group and stuff, but error group is a super handy thing to use if you're spinning up multiple Go routines and you want to abort if any of them error instead of like running them forever or something. So it's part of the standard library. Oh gosh, that's not what I wanted. It's in the xsync error group package, and it gives you a context, and
does it immediately kill the other utilities?
it does it through context cancellation. So as soon as one of them returns an error, it will call cancel on this context. So it's up to your Go routines to be monitoring that context and respecting it, which is always the case with Go, basically. There's no way, I believe, to kill Go routines, whatever. Like you can either take down the whole process or you can do context cancellation. But we demoed earlier using the timeout idea that you can pass a context to a page. So I can pass in that context for error group and when I'm loading a page. And so Rod will respect that context. And if something errors, then it will kill the other tabs or whatever. And then you just wait for them all to finish. So the thing you look at here when we run the test is that you'll see it load 2 pages and then pause for 2 seconds and then start loading more pages. That just sort of proves that the page pool is working and not just spinning up all 4 at once. All right, so 2 pages loaded, and then they get closed and the other ones start loading. So you can limit it to, whatever, 20 tabs or something, whatever can fit on your server or your machine that you want. And that's basically it. I guess I wanted to, I don't think there's any words. Yeah, okay. So I wanted to say, like, be a good citizen. If you're scraping a site, you could pretty easily, especially with Go and stuff, you could accidentally spin up 10,000 or 100,000 Go routines that are all hitting a site and DDoS it, or really it's not DDoS, it's just DOS, denial of service attack, and maybe get yourself blocked, whatever, take down the site for other people, right? So just think about what you're doing, be a little cautious. I would say, like, it's a good idea to figure out some sort of caching thing pretty early so that you don't have to hit the site over and over. Some sort of rate limiting so that you don't send 10,000 Go routines. And I'm blanking at the moment, but there's a built into the standard library useful tool. So just, I might look it up. It's like a semaphore in the standard library, so you can tell it. It's like the page pool idea. You can tell it instantiate the semaphore thing with 40 slots available, and then you can spin off Go routines and stuff. And just like the page pool, it'll limit how many are active. So yeah, just think about what you're doing because you are potentially a pretty powerful abuser if you're not careful.
How many times have you knocked the NCAA offline?
NCAA has rate limiting, and I've been rate limited quite a few times. And the last thing, I didn't think there'd be enough time, and basically I'm correct to go into this next layer. But I just wanted to mention we found it really useful to put the web scraper behind a REST API. That then means if you're already like a backend developer or something, you potentially already have tools that handle caching and rate limiting and stuff for APIs. And so you don't really have to like reinvent the wheel there. And it also provides a nice way to get the data to different programming languages potentially. When you're working with data, like it's pretty nice to be able to scrape it in Go, but you might want to analyze it in Python or R or something. And so writing the scraper in Go, but then with your Python code, just being able to suck it in as a REST API it's pretty handy. So just throwing that idea out there.
Does Rod have facilities that'll help you in case that the content is paginated? Like for example, even Amazon, it'll do first 3 lazy load up to 25 or 50 based on what your preferences are, and then
Yeah.
to the next to get the next batch.
Just in the sense that at a raw level, you can look for those next links and you can click them. So you can scrape the first page, find the next link, and then there's click events you can send. Anything you can do, really, you can tell it to do.
So since it's actually running the JavaScript, if that click event is a JavaScript that just simply reloads that div,
Yep.
it can still happen.
Yep.
Okay.
So you can, we haven't used some of those more advanced sort of GUI features, I don't know, whatever you want to call it, but you can manipulate the size of the window, like which sometimes matters. You can send click events. Trying to remember some of the other things you could do, but yeah, basically anything you could imagine doing is pretty much available.
And can you capture the CSS itself? And I know it seems like most of the time CSS uses a selector mechanism, essentially they say lookup table, but can you say the CSS itself during the ROD package?
You definitely could download the CSS files, like that hijack request thing. Okay. You could say if it's a CSS, download it.
Oh, okay.
Like don't block it, but download it and store it in my disk or whatever. I don't know if there's a way to access like the rendered CSS, like.
Right, really kind of like snapshotting that element, however the way it's.
Yeah, like trying to preserve it or whatever.
Yeah.
Yeah.
Like a thumbnail.
That's one of the other things maybe worth mentioning is like if you're just using raw HTML, it's pretty easy to capture the content. But if you start getting a JavaScript world, it gets pretty hard, and like you may have to send click events over and over and stuff like that. Like you can't really capture the full response.
And one final question, I think. On the flip side, if I wanted to prevent someone using any of these tools, the modern tools, from scraping my site, what are some things that you've kind of experienced that basically made you kind of pull your hair out and think, why did they do this?
They all have the same ID in class.
yeah. Just give everything. Just use really horrible CSS selectors. That'd be funny because they do have like the JavaScript obfuscators. I wonder if they have like a CSS obfuscator or something. The other stuff would be like there's not really probably a great way, but by default, if you're using the Go HTTP and stuff, like it's gonna have a user agent that says Go. Like it's a pretty lame way to block someone, but you could block like the Go HTTP agent. Ultimately,
it's going to be hard because
it looks like Chrome. Yeah,
it is a browser.
So ultimately, you'll see if a certain IP is hitting your website 50,000 times or something, and you can have rate limiting. So yeah, I mean it's sort of a pretty standard feature now that if you don't have some sort of denial of service protection, you're likely to get denial of service. And in some ways, a scraper is just a denial of service attack in a way. I mean, it's not crossing the line to where it's denial of service, but it's potentially an abusive user.
You could probably do some sort of like anomaly detection, like if he's blocking images in CSS. Like if you see that, you're like, okay, this can't be a real user, and I'm not going to serve.
Yeah, and
I take a lot on some of that, given some of the screen readers
Yeah.
for accessibility reasons, could skip certain aspects.
Sure. And some of those are pretty, I mean, you have to be basically writing your own server to do timing, attack,
Yeah.
detection, things like that.
Well, you can
like cool, but
if you're running in like Google Cloud or something or any provider, they all have denial of service protection type stuff, and you can rate limit things. Obviously, you got to pay for it, but
I mean, obviously, there's good useful uses for the technology, but there's always also bad uses for it.
Yeah.
So good to know both sides of the
Yeah.
arguments.
It's the white hat hacker, right? I wanted to just mention for each of these tips, I documented sort of where you would find it in the documentation for ROD. So if the code here is not sufficient for you, you can click the links and check out the docs. One of the things I mentioned we would double check is custom browser launch. So it's documented here in the guides, custom browser launch. And yeah, it's like here, as an example. It's a little small, but so you can tell it the binary to use for your browser, so it won't download it, and then hopefully it'll be signed, and the antivirus will trust it. And I don't know, or maybe it's leakless itself that's not signed. I don't know, but there's that. And then someone else had a question. I forgot what it was. Any other questions?
I just ask. So I mean, this is obviously working out really well for you. You seem less in love with like the ROD library, underneath it on some of the choices they made and that sort of thing on how they're expressing something.
Oh, that's just because I'm a critical person. It's pretty darn good.
Okay. I was just going to ask because like every other language.
I didn't curse once, for example.
Okay, I have to get to know you better first. But, every other language ecosystem I've worked in on anything like this has used Selenium WebDriver as opposed to, instead of ROD. So do you actually like the API better than that? Is it simpler? You give me a kind of compare and contrast there?
So I haven't used Selenium, and given that Selenium's been around longer than DevTools protocol has, but I would assume that it has switched to using the DevTools protocol.
Okay.
It was a predecessor to the DevTools protocol, and I think was mostly focused on testing. There is a lot of similarity between scraping and testing, and so it might be a perfectly viable tool, but I don't know.
Apparently there's Selenium clients if you really want to use it in Go.
And then if you go to like Rod's page, like it'll link to like 5 other browser driver things, and if you go to Kali or GoQuery, it'll link to like 15 other packages. Like there's lots of options out there. I'm not claiming these are the best or anything. Just these are ones that I dabbled in. And
yeah, I feel like I got to put on my developer advocate hat too for Grafana, because we have a load testing product called K6 Browser.
Okay.
I don't know what it uses under the covers, but it's kind of does scraping for load testing purposes. And you write your scripts in JavaScript, but it's actually the application is written in Go and interprets your JavaScript. So it's kind of I don't know. It's kind of interesting. I'm kind of wondering, have you ever tried that?
I haven't used that. We've used. I'm trying to remember the name of it right now, but there's a load testing app that's pretty popular. I think it's Python World.
The Gatling or something like that, or
yeah. Locust.
Oh yeah.
So
it sucks compared to K6. Just so you know. K6 is fully open source, so.
Yeah, I haven't used Locust much either, so I don't really have an opinion about it either. But I do like Grafana, so.
Yeah.
So it seems, obviously, I've worked with these, so I have a bit of background on the specific stuff that you're pulling down with this, but with that particular web page, that's something that once the game is done, that's probably not changing that much. If you were going to scrape something that was periodically updating, or something that was more on the order of like live scraping or something of scraping every couple seconds. Like you had that you mentioned earlier, you're like, I'm pulling down that site periodically, looking for that site to see when something goes live and I want to buy it. Like, is this still like a tool that is reasonable for something like that? Or is this, is it worth it to try, and deploy like a live scraper like that using a different framework?
I think it's perfectly reasonable. If it's something simple, using ROD might be overkill, but just the live aspect of doing it over and over, it's very fast. For example, many of these pages on the NCAA website might take 10 seconds to load, and it's scraped and parsed in like 100 milliseconds or something. So the scraping and parsing is very efficient.
Is speed a factor for your performance, or is it just eventually when I get it right?
It's not much of a factor. We would like as little latency as possible, but like ultimately the 10-second load page on NCAA means that the performance of the program itself is nowhere near being the bottleneck. So if you're scraping a live thing, and if it's a particularly good web developer, the resources may have e tags on them, and you can do a head request, which is very cheap, and it will tell you the e tag for that resource. So I was kind of curious if NCAA does. It's probably something I should have thought of a long time ago. I wonder if this will show me. Yeah, it is. So theoretically, you could do head requests, check this e tag, and then only scrape when you see the e tag changing.
I was about to ask if there was like some hashing or something you could do to just check.
Yeah.
That's
what e tags purpose is. Now, you would have to verify that these e tags are actually meaningful. They could. I'm trying to think if I've ever actually seen this or not, but like a site could maybe be constantly changing in a not very meaningful way, and so then the e tag gets changed, and so it doesn't really help you know when you want to scrape or something. And it might also lie and tell you the e tag hasn't changed when the site has, I suppose. But hopefully developers aren't doing that, because that'd be a pretty big violation of HTTP spec, I think. Pretty sure that e tag is considered to be a way to cache HTTP responses.
So then it's really it's basically like you're operating against like your upper bound of like hitting it, and most likely in the sense that it's either constantly changing. At worst, it's constantly changing because it's related to something with like time or something. Even the web page itself isn't changing. The tag is just updating, iteratively or consistently. In which case, you're going to be hitting it as often as you would otherwise.
Right. So then don't bother.
So then it doesn't bother.
Yeah. All right. Any other questions?
If so many people are scraping that NCAA website, why don't they just provide the rest of it?
Yeah. You know what's even worse is I'm pretty sure there's signs that this is like a Ruby app with an API backend. They just don't make it publicly available. And I assure you, a lot of people are scraping this site. Like,
Yeah.
Anybody familiar with the Ring system, security system? They look like they've got a terrible API. So I wanted a way to just go through there and look at all the batteries in my system and see which devices have batteries that are running down that I need to change the battery. But if you go through the app too, it's terrible. So you have each device health, look up the battery percentage, and all that. So I wanted to write a routine to do that.
yeah, that's a good example of web scraping.
Web scraping.
Yeah. It's because they're hardware people.
I think that's a really good point. There's actually a local radar type company called Rapsodo that builds like radar devices to track or like golf simulators, or for baseballs if we want to track like information on that. It was something that we had in college, and they not only did they have no way of like, there's no API, there's nothing you could do to like actually pull down. You couldn't even do like an export to CSV or something to get anything. And it was just a super cumbersome app to try to go through. And it was basically set up to be like, they were clear, it was very clearly that the focus was on the building the hardware to be able to record the information rather than building the UI to interact with it.
Yeah.
I don't know if that's still the case, 4 years later, but I can't imagine that they've had too many improvements on that front. It's not the focus.
Yeah. They just didn't want to pay for those front end folks or the web folks.
Well, usually they develop the API first on modern apps, and then they use front end code to hit the API and their goal, right? But on old apps, they might not have done it.
It's a classic middleware problem. I mean, the only problem with the NCAA, her question, is that they'll sue you if you try to create middleware for that.
Yeah, probably.
Because they will. We can give you a shit interface, but that's the only face you have to have.
Yeah.
In answer to your question earlier about defensive techniques for web scripting, the answer is J3 tags or TLS fingerprinting. I had a friend who once tried to circumvent that.
Okay.
It's a tricky matter.
Is it? Well, we'll talk more about that now. I'm curious.
So what did you say? Browser fingerprinting and
JA3 tags, they're TLS fingerprints.
okay.
Yeah, I put on a Slack channel one time, do you like this library or that library? The response I got back, why use this library? Just use the standard library and write it yourself,
Yeah.
So,
Yeah.
Sometimes it's correct.
It's rarely correct.
So sometimes.
Correct.
it depends on the quality of the library you're using,
So there's a
right?
chance.
And
Yeah.
how much effort it's taking.
Proverbial software development problem is like, why aren't you saying it the way I'm saying it?
Yeah.
There are now 19 competing seconds.
Exactly.
Yeah.
And there's only 10 people in the room.
Well, we've learned a lot
Yeah.
since we started the first 10. So
Yeah.
Yeah, legacy.
We already plays the applications for an hour and 20 minutes.
Yeah.
All right. Now, normally I try to have giveaways. I'm very low on them at the moment. And these are actually leftovers from a couple weeks ago. So I have very limited sizes. This is from a company called Trace Test. And I don't want to keep carrying them in my bag. So please, anybody help yourself. Stickers, always, everybody loves them. So anyway, but yeah, that's all I got for the giveaways. Let's see, I think I went one slide too many. Okay. All right, so the next event is actually for the Kubernetes and Cloud Native STL group. That will be also at OCI. So again, this is the farewell tour for Cortex as far as my events go. But yeah, so that'll be me presenting on creating reliability pipelines with Kepton quality gates. So that's going to be fun. That's going to be going through and then just a deployment pipeline, and then it'll do some checks with some metrics in the back end against Mimir or Prometheus, and then do checks to make sure that we're good to go, and then it'll kill the pipeline if not. So that'll be on the 18th. Then May 24th is the next scheduled for the Gopher meetup group. No topic assigned, so if anybody is interested in actually doing a presentation or whatever, I'm more than happy to help you out. Like I said, I'm one of the GoBridge ambassadors for trying to do speaker support, things like that. So if you're interested in doing talks, in groups or submitting to GopherCon or that type of a thing, even though I didn't get accepted on my last
What
one.
was your talk supposed to be?
Well, I don't know. I don't want to give it out too much, but no, what it was going to be is, all right, so it was going to be why you should be a doomsday prepper. And then it's all in the software thing about just about doing all kinds of load testing and all kinds of extra testing beyond just the unit tests. So, but yeah, so I thought it was going to be fun, but I don't know, it just didn't get
Now,
picked.
GopherCon that's international, right? So
It is.
yeah,
It is. It
I've
is.
seen some of those things on YouTube.
Yeah,
Good
yeah.
presentations.
Nah, it's yeah, GopherCon UK. They I think that one's still in the queue. So we'll see. We'll see if I get picked for that. But anyway, but yeah. So like I said, that's probably going to be one of the topics coming up. I don't know if it'll make it on this one, but yeah. So definitely, if you're not already, subscribe, please. Anybody that's watching out there and that on the internet, please like the video. Smash that like button. Subscribe, all that good stuff. So anyway, that's it. Thank you everybody for attending. Hopefully, keep coming.
Presentation and the code being posted.
I have, Nathan, whenever you can get me the slides, I'll add them to we have a GitHub repository where I keep all this stuff. If you actually go to StLGo.org/repo, it'll take you right there. And then that's where all the presentation files for the history of, since I've been running them, of the group are located. And yeah. All resources will be there as well. And then you get to find out what beers I was drinking during COVID for each one. Yeah, I always had some beers for the meetups. But yeah. Well, thank you very much.
Thank you.